Okay, here we're going to graph secant and cosecant, but first let's do it on Desmos and see what this thing looks like. So y equals secant x. You'll see here, kind of looks a little weird. And let's graph cosine right there with it. So y equals cosine x. Secant is 1 over cosine, remember? And so you can see there's some sort of relationship with cosine. Wherever cosine is 0, you get vertical asymptotes for the secant graph. All right, and so let's see how we can graph this on paper. Okay, so here we have y equals secant x. We can think of that as 1 over cosine x. And we know from algebra, whatever makes the bottom 0, if it doesn't cancel, you're going to get a vertical asymptote. All right, so we're going to use cosine x as a guide to graph secant x. All right, so we know the graph of cosine has an amplitude of 1 and a period of 2 pi. All right, so I'm going to mark out some distance here, 2 pi, and I'll do half of that, and that'll define my scale. Scale on the y-axis is from -1 to 1. All right, that's my y-axis. My x-axis, so halfway we get pi, half of that is pi over 2, and this is our standard scale, right? Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so what I'm going to do is graph cosine, right? And we know cosine starts at 1, ends at 1, halfway we get our minimum, and then our roots there. But I'm going to graph it dotted because this is actually just a guide. This is going to be a guide that's going to allow me to graph the secant graph. All right? And so wherever cosine is 0, right, we have a root here and a root here. Wherever cosine is 0, we get a vertical asymptote for the secant graph. So I'll draw that in right there and here. And then we'll graph that reciprocal relationship. Now, what do I mean by the reciprocal relationship? For example, if you have cosine of, let's say 60 degrees, we know that's equal to 1/2, right? And so secant of 60 degrees is 1 over cosine of 60 degrees. So 1 over 1/2 is actually 2. So the reciprocal of 1/2 becomes 2, and it gets bigger. Now the reciprocal of 1 is just 1, so they're going to share these points right here. And then that reciprocal relationship gets bigger, and then it has to be asymptotic to the vertical asymptotes. And so that's going to happen on the negative side as well. And then over here. So what I have here is 1 period for secant. On Desmos, we saw many periods. All right, this is 1 period. And then after this period, it's going to start to repeat. And you'll see this, piece go up, and there'll be another asymptote. Right, that'll go up, and there'll be another asymptote. So for now, we're just going to draw in 1 period, and then I'm going to come back, and I'm going to erase the cosine, which is a guide. Erasing that guide is optional. You can leave it in there. But that in green is the actual picture of secant. Okay, here we're going to graph cosecant. So remember, cosecant is 1 over sine x. So wherever sine is 0, we're going to get those vertical asymptotes. All right, so we know how to graph sine. The period, again, is 2 pi. So I'll mark out a space there, and I'll graph 1 period for sine. Half of that. And we have pi, pi over 2, and 3 pi over 2. All right, 1 and -1. Okay, so for sine, we know it starts at 0. It ends at 0, it has a root in between, goes to its max, and its min here. And again, I'm going to draw this in dotted, because this is just a guide that I'm going to use to graph cosecant. Now, wherever sine is equal to 0, you're going to get a vertical asymptote. So I have one here, draw that in. I have a vertical asymptote here at pi, and another vertical asymptote here at 2 pi. Okay? And then from there, you draw in the reciprocal relationship. 1 over 1 is 1, so you just get the graph kind of looks like this. It looks like a parabola, but it's actually asymptotic to these asymptotes. So it looks more like a U. A parabola is not asymptotic to anything. So it's definitely not a parabolic shape. But there you go. That's the graph of cosecant, one period. Anyways, and then it's going to start repeating forever if I draw in more periods. And then I'll come back and I'll erase that guide there. It's not part of the final graph. So there you have it. Let's have a look at cosecant on Desmos. All right, so we did secant already. Now let me go ahead and graph y equals cosecant. And so there you go. And we were looking at, from 0 to 2 pi, which is around 6. And we'll compare that to the graph of y equals sine, right? And you can see there, right, there's sine graphed. And wherever sine is 0, you do get those vertical asymptotes. All right, so there you have it. The graph of cosecant continues in that way forever in both directions.